Hi guys, this is AS Chemistry, Mass Spectrometry. Question 1. The diagram shows the mass spectrum of a sample of naturally occurring copper. What is the relative atomic mass of this copper? So according to the mass spectrum given, we have two isotopes of copper present. The one having a mass of 63 has a relative abundance of 7, and the one having a mass of 65 has a relative abundance of 3. So, in order to calculate the AR, we must calculate 7 upon 7 plus 3 is 10 into 63, and we add this to 3 upon 10 into 65, the sum total of which will give us a value of 63.6. So, this makes option C the correct option for this question. Question 2. The diagram shows the mass spectrum of a sample of zinc. Use the data to calculate the relative atomic mass of the sample. So we've got three isotopes. Isotope with the mass of 64 has a percentage abundance of 40. Isotope with the mass of 66 has a percentage abundance of 30. And the isotope with the mass of 67 also has a percentage abundance of 30. So in total, 40 plus 30 plus 30 gives us 100%. So in order to calculate the AR, we must divide 40 by 100 and multiply it by 64. Add this sum to 30 upon 100 into 66. Add this to 30 upon 100 into 67. The sum total of which comes to 65.5. So this makes option C the correct option for this question. Question 3. A sample of chlorine containing isotopes of mass numbers 35 and 37 was analyzed in a mass spectrometer. How many peaks corresponding to the Cl2 positive molecular ion were recorded? So, a molecular ion consists of two chlorine isotopes, and there are two possible masses of the isotopes. So, in the first probability, we have a molecular ion with both the isotopes having a mass of 35. So, this gives us a total mass of 70. Another possibility would be one of the isotopes having a mass of 35 and the other having a mass of 37, giving us a total mass of 72. A third possibility has the Cl37 isotope at the first position and Cl35 isotope in the second position. This also has a mass of 72. And another possibility has both the isotopes having a mass of 37, giving a total mass of 74. So the number of peaks correspond to the masses of the molecular ions, which would be one peak for mass 70, one peak for mass 72, but there are two possibilities for this mass to be present, and one peak for the peak having a mass of 74. So in total, three possible peaks may be present in this sample, making option B the correct option for this question. Question 4. The isotopic composition of an element is indicated in the diagram. What is the relative atomic mass of the element? So this element has two isotopes having a mass of 10 and an isotope having a mass of 11. The one with the mass of 10 has a relative abundance of 1, and the one having a mass of 11 has a relative abundance of 4. So in order to calculate its AR, we must divide 1 by 4 plus 1 is 5, multiply this by the mass of 10, and add it to the ratio of 4 upon 5 into 11. So this gives us an AR value of 10.8. So this makes option C the correct option for this question. Question 5. An element X consists of 4 isotopes. The mass spectrum of X is shown in the diagram. What is the relative atomic mass of X? So the isotope with a mass of 90 has a percentage abundance of 50. The isotope with a mass of 91 has a percentage abundance of 10. The isotope with the mass of 92 has a percentage abundance of 20. And the isotope with the mass of 94 also has a percentage abundance of 20. So in order to calculate the AR, we must add together the ratio of 50 upon 100 into 90 added to 10 upon 100 into 91 added to 20 upon 100 into 92 added to 20 upon 100 into 94. This gives us an AR value of 91.3. So the correct option for this question is option B. Question 6. The relative atomic mass of copper is 63.5. Which chart is a correct mass spectrum that would lead to this value? So option A has a single isotope with a mass of 63.5. Copper will not have a single isotope, it will have more than one isotope. And usually the isotopic masses are in whole numbers and not in decimals. So the mass of the single isotope represented in the mass spectrum A has a mass of 63.5, making this option incorrect. For option B, we will calculate the AR value because there are three isotopes present. So the calculation would be 17 upon 100 into 62 plus 33 upon 100 into 63 plus 50 upon 100 into 65. This would give us an AR value of 63.83, making this option incorrect because the AR value for copper is 63.5. We will carry out the same procedure as we did in option B for option C. In option C, there are two isotopes. The first isotope has a percentage abundance of 74 and a mass of 63, and the second isotope has a percentage abundance of 26 and a mass of 65. So when we add these two values together, we end up with an AR value of 63.5, which is the correct AR value for copper. So this makes option C the correct option for this question. Question 7. The mass spectrum of a sample of lithium shows that it contains two isotopes, Li6 and Li7. The isotopic abundances are shown in the table. What is the relative atomic mass of this sample of lithium given to 3 second figures? So in order to calculate the AR, we will perform the calculation of 7.42 upon 100 into 6 added to 92.58 upon 100 into 7. So when we add these two together, we end up with an AR value of 6.93, and this makes option D the correct option for this question. Question 8. A sample of element X is analyzed using mass spectrometry. The mass spectrum obtained is shown. What is the relative atomic mass of the sample of element X? So in order to calculate the AR, we must perform the calculation of 3 upon 100 into 112 added to 56 upon 100 into 114 added to 41 upon 100 into 115, the total of which gives us an AR value of 114.4. This makes option D the correct option for this question. Question 9. Oxygen has three stable isotopes, O16, O17, and O18. All three isotopes are present in a sample of oxygen gas, which was analyzed using a mass spectrometer. How many peaks associated with the O2 positive ion would be expected? So, in an O2 positive molecular ion, there are two oxygen isotopes present. So, if we see which isotopes are present, we will have a combination of the first isotope having O16 and the other isotope present also having a mass of O16. So in total, a mass of O32 for the molecular ion. A second possibility would have the first isotope being O16 and the second one being O17, this giving us a mass of 33. Third possibility would be the first isotope being O16 and the second one being O18. This gives us a molecular ion mass of 34. Next possibility would be the first one being O17 and the second one also being O17. This possibility also gives us a mass of 34 for the molecular ion. A fifth possibility would be the first atom present being O17 and the second one being O18, giving us a mass of 35. And the last probability would be both the oxygen isotopes present in the molecular ion having a mass of 18, giving a peak at mass of 36. So in total, first peak would be present having a mass of 32, a second peak would be present having a mass of 33, a third peak would be present having a mass of 34, corresponding to two different molecular ions, a fourth peak having a mass of 35, and a fifth peak having a mass of 36. So in total, five possible peaks are present, making option B the correct option for this question. Question 10. The mass spectrum of an alloy of copper and gold is shown. Which expression can be used to calculate the relative atomic mass AR of copper present in this sample? So, the isotopic masses of 63 and 65 correspond to isotopes of copper, whereas the isotopic mass of 197 corresponds to the isotope of gold. So, in order to calculate the AR of copper, the value of 197 or the percentage of 18.50 must not be present in the formula. So this eliminates options A and B because A and B have these values present, C and D do not. So now in order to calculate the AR of copper, we must have 56.36 multiplied by 63 in the numerator added to 25.14 multiplied by 65 in the numerator and divided by the percentages of each isotope in the denominator, which would be 56.36 plus 25.14. This should be the calculation for AR of copper. This is what is present in option C and not in option D, because in option D, the masses of copper isotopes are present, which is incorrect for the calculation of AR of copper, making option C the correct option for this question. Question 11. The element sulfur produces a mass spectrum with the following peaks. Which relative atomic mass of sulfur can be calculated from these data given to four significant figures? So in order to calculate the AR of sulfur, we must do 95.02 upon 100 into 32 added to 0.76 upon 100 into 33 added to 4.20 upon 100 into 34 added to 0.02 upon 100 into 36. This gives us an AR value of 32.09. So this makes option C the correct option for this question. Question 12. Which statement is correct? Chlorine has a relative isotopic mass of 35.5. No, it has a relative atomic mass of 35.5. Cl2 has a relative molecular mass of 70. No, it has a relative molecular mass of 71. ICl has a relative molecular mass of 162.4. So if we add together the AR of iodine, which is 126.9, and we add the AR of chlorine, which is 35.5, we do end up with 162.4. So this is correct. And in option D, we have got NaCl has a relative molecular mass of 58.5. NaCl is an ionic compound. It will not have a relative molecular mass. In fact, it will have a relative formula mass of 58.5. So eliminating options A, B, and D makes option C the correct option for this question.